Hi all, I am Matteo Ciniselli and will present an empirical study on the usage of BERT models for code completion. Code completion is the capability of a model to predict the next few tokens to speed up code writing for developers. Here you can see an example where a code completion tool is suggesting some token to the developer. Our aim is to run a large-scale study in which we explore limits and capabilities of deep learning model to support code completion. We chose Roberta model, a BERT-like model, so based on transformers, that uses a training task where random tokens are masked with a special mask token, and the model tries to predict them, and in this way it can learn the language. We modeled our study on two different sets, Java that contains generic Java files and Android more focused on Android APIs. For Java we have the raw code, so the code as written by the developer, and the abstract version, where we replace some token with a special placeholder that keeps track of the kind of token, method, variable, and an ID that uniquely identify each of them. We have the same thing also for Android, and we came out with 600 3000 Java methods and 500 3000 Android methods. We split them into training set 80%, evaluation set 10%, and test set 10%. We evaluated three different code completion scenarios. Token and masking, in which mask a random number of tokens at the end of a line. You can see here an example in the third line. This approach is usually done in the literature. Construct and masking, in which we mask a specific construct if, for, while, because we believe that these can be very useful for code completion. You can see here that all the tokens inside the round brackets have been masked. And finally, the most challenging scenario, block level masking, in which we mask an entire block. You can see here that all the tokens inside the curly brackets have been masked. So, for the training we pass this masked method to Roberta, and Roberta uses the prediction to adjust the weights. The same thing happens also for evaluation and testing, but in this case the model has been retrained, and so we'll look at the prediction. Let's see some results. On the x-axis of our graph we have the number of masked tokens, and on the y-axis we have the percentage of prediction that the model correctly addressed. This graph refers to token masking scenario, the easier one, on raw source code. We can see that Android works better than Java, since the red line is always above the orange line. We can also see that when the number of tokens to predict increases, then the performance is decreased. In this second graph, we added two more lines for abstract version. We can see that abstraction helps, since the dotted lines are always above the continuous lines. The final graph shows a comparison between the token masking on the left and the block masking on the right. We can see that when the task became more challenging, the model shows a huge drop. So Roberta is not yet ready to predict entire statements. I finish my talk. Thank you for listening.